So for this objective, we are going to be combining like terms. And before we look at problem one, I want to talk a little bit about operationally why this is acceptable with an equation. All right. So even though we've got our first problem here, I want you to just kind of ignore that for a second. And I'm going to write underneath it. In fact, I'm going to do a little squiggly line just to kind of separate the two. So I'm going to write underneath here. So ignore this for a second. We'll get to problem number one in just a moment. But what I want to talk about is this concept of how we're able to manipulate equations. All right. So if I have just very simply the number 2, and I say that the number 2 equals the number 2. Okay. All right. Duh. Right. I mean, that's right. Who cares? That's pretty obvious. How is it then that I'm able to manipulate the two sides of an equation like we're going to manipulate up here? Okay. So in just a moment, the first step we're going to do is we're going to subtract 6 from both sides, okay? Spoiler alert, that's what's coming. So how are we able to do that? Well, if I say 2 minus 6 on this side, that gives me -4, okay? In order for this equation to stay true, I have to get this side to equal -4 as well. Well, how am I going to do that? Well, I'm going to subtract 6 from this side as well. So the equation statement is still true. -4 does equal -4. All right, so if I do something to one side of the equation, the reason why I must do it to the other side of the equation is I must maintain the truth that the two sides are equal. All right, so let's use multiplication for an example instead. So if I multiply 2 by 3, that's going to give me 6. Well, in order for 6 to equal 6, I have to do the same thing that I did to this side of the equation to this side. So I'm going to multiply this side by 3. And so the reason why on this type of an equation we're able to manipulate, to add and subtract and multiply and divide as long as we do it to both sides, the reason why we're able to do that is because that will hold true so long as we do it to both sides. Whatever you do to the left, you have to do to the right. And the reason why is we have to maintain that the two sides are equal. Okay? All right, so let's go ahead and start on problem number 1. So, as I stated previously, I'm going to subtract 6 from both sides. Okay? But what I'm actually doing is I'm combining my like terms. Okay? So this concept of like terms, what does that mean? That just kind of sounds gobbledygooky. It's verbiage, it's vocabulary. What is a like term? Well, in this case, my 6, that doesn't work. My 6 and my 10 are both constants. They're numerical values that are not being multiplied or divided by a variable. Whereas my 8x and my 6x, they both are variables for x. Okay? So essentially what I'm doing here is I'm going to combine the 6 and the 10 and the 6x and the 8x. But I can't just add 6 to 10. I have to eliminate the 6 from this side in order to only have this one constant. And then I'm going to eliminate the 6x from this other side to eliminate and just end up with one variable. Okay? Because ultimately what we want to get to is x equals something in this particular example. Okay? So continuing on, I'm going to subtract 6 from both sides. 6 minus 6 here will give me 0, so that essentially eliminates this. And then 10 minus 6 will give me 4 here. And then I want to rewrite 8x equals 6x plus 4. Now the rewriting is pretty important because especially when we're trying to find errors here, we want to see our steps. Okay, so make sure you're writing those out. All right, so now I want to get rid of this 6x. So I'm going to subtract 6x from this side. But since I've done it to the right side, I now also have to do it to the left side. So 6x minus 6x is going to give me 0. 6x minus 2x, or excuse me, 6x, 8x minus 2x, goodness, my brain's going faster than my mouth, will give me 2x. All right, so I'm going to end up with 2x equaling 4. All right, and so then it's just a matter of dividing by 2, and so x equals 2. Now, what I can do here is I can plug that back in and make sure that that's true. So if I say, okay, x is 2, so 8x, which would be 8 times 2, would give me 16. 6x, which would be 6 times 2, would give me 12. So I've got 6 plus 16 equals 12 plus 10. That works, because 6 plus 16 is 22, and 12 plus 10 is also 22. So there's my check that this is actually correct. All right, so for this particular problem, again, with this objective, we are working on simplifying equations and combining like terms where we've got variables on the two sides of the equation. All right, so for this particular scenario, we're given a scenario where we have a rectangle, and the area of the rectangle is equal to the perimeter of the rectangle. And then we have to find what the value is of one of the sides. So we're given one of the side lengths is 3, but we don't know the length of the other side. So this is ultimately what we're trying to figure out. So we're going to set up this very simple equation that the perimeter is equal to the area. And then we're going to kind of work backwards from there. So perimeter for, and I'm going to use a couple of different colors. I'm actually going to change area to a different color so we can keep them separate. All right, so for perimeter, we've got 2 times the length plus 2 times the width. All right? Now, our width in this case, we're told is 3. So we've got, and I'm going to change L to X because X is the value of our length here. So I'm going to go ahead and erase the L and go ahead and put an X here just for consistency. So we're going to have 2X plus, and then 3 is our width, 2 times 3. All right, so here's our perimeter expression for the left side of this equation. All right, and then for the right side of our equation, for area, we know that area is just length times width, but I'm going to change my L again to an X for variable's sake, and then our width is 3, so it would be X times 3. So I'm going to rewrite this, and I'm actually going to rewrite it in, should write it in a different color. Should write it in green. So we're going to have 2x plus 6, 2 times 3 is 6, is equal to 3x. All right? And now it's time to simplify the equation and then combine those like terms. All right? So this one's actually, the hard part is just the setup, is just figuring out how to get this set up. All right? Because now it's just a matter of, I want to isolate x, and the easiest way to do that is to subtract 2x from both sides. So I'm going to subtract 2x from the left side of the equation, and I'm going to subtract 2x from the right side of the equation. 2x minus 2x is going to give me 0, and then 3x minus 2x is going to give me 1x, but I'm just going to write that as x. I'm going to rewrite, and I'm left with 6 equaling x. Now if I wanted to go back through and double check that, wouldn't be too hard. So if x is 6, that means the area is going to be 6 times 3, which would be 18. And then for the perimeter, if x is 6, I've got 2 times 6, which would be 12, plus 6 is 18 for the perimeter. So that checks out. So for this problem, we are given a scenario where we have 2 people and they start out with a set number of pieces of gum, and then they give some gum away, and then we've got to figure out how much gum did they give away, or how much gum did Julie give away. So I've written down kind of the pertinent information from the problem that we're given. So Julie starts out with 20 pieces. She gives X number away. We don't know how many that is. We're going to use X as our variable. And then Conrad starts out with 35 pieces, and he gave away twice as many as Julie did. So we'll talk about what that looks like. So the first thing we're going to do is we need to create a simple equation. So we're told that they started, how many pieces did they give away if they had the same number of pieces of gum left? So what we're basically saying is, after the dust settled, after they'd given away what they'd given away, they ended up with the same amount. So we know we're going to have an equation because they had an equal amount at the end. So basically, at the end, J is going to be equal to C. All right. So now we need to create an expression for each of those, and then combine our like terms. So for Julie, she started with 20, and she gave away X. So if I've got something, and I'm a group of something, and I'm giving stuff away, what's that going to do to my total? Well, it's going to reduce it. So I'm subtracting in this case. So 20 minus X is our expression for Julie. And then for Conrad, he had 35, started out, and he also gave away, so we're subtracting, and he gave away twice as many as Julie did. Well, if Julie gave away X, we don't know what that is, but we do know that Conrad gave twice as many as X. That means he gave away 2X, because it was double whatever Julie gave away. So this is the equation we're starting out with. It's 20X, or 20 minus X, excuse me. 20 minus X is equal to 35 minus 2X. Now, once we get to here, then it's just simply a matter of solving for X. So the way we do that, and I'm going to do this a little bit differently because I don't like my variable and coefficient. I don't like it to have a negative in front of it. I like to get rid of negatives. I find I'll make less mistakes if I've got fewer negatives involved. So I'm actually going to add 2X to both sides. So I'm going to combine my X's by adding 2X to both sides. So here I've got minus 2X, so if I add 2X to it, that's going to give me 0. And then if I've got negative X and I add 2X, that's going to just simply give me X. Okay? So I'm going to have 20 plus X is equal to 35. All right? Now I need to combine my constants, so I'm going to subtract 20 from the left side and subtract 20 from the right side. So X equals 5. All right, so a quick check of that. If X is equal to 5, no, sorry, X is 15. Because I just did a mental check and realized I'd made a mistake. And that, ladies and gentlemen, is why you want to check your work. All right, so if X is 15, 20 minus 15 is going to be 5. $35 minus 2X, 2 times 15 would be 30, would also give me 5. So my question, or my solution, I should say, my solution checks out. And hopefully you're watching the video going, Mr. Beckwith, 35 minus 20 is not 5. Hopefully you caught that. I didn't, obviously. So just doing that quick check, plugging my solution back in, that actually prevented me from getting, some obnoxious emails from some of you letting me know that I made a mistake on that one. So for this question, we're given a scenario involving congruent angles. And so remember, if an angle is congruent, that just means that if the two angles are congruent, that just means the angles are equal. They have an equal value. All right, so our first angle we're given is 5x is equal to 5x plus 24, and our second angle is equal to 9x minus 17. And so because we know they're congruent, we know that this value is going to need to equal this value, and then we have to simply just solve for x. All right, so I'm actually going to start with my constants this time. And I'm going to, because I don't like dealing with the negatives, I'm going to add 17 to both sides to get rid of this minus 17. So I'm going to add 17 here to get 0. And then I'm going to add 24 and 17, which should give me 41. All right. So we've still got 5x plus 24, or excuse me, 5x plus 41 equals 9x. And now I want to get rid of my 5x over here. All right, so I end up with 41 equals 4x. And I need to divide both sides by 4. And so x is equal to 10.25. So for this problem, we're actually given a model. Now, I've gone ahead and converted the model into the actual equation, but make sure when you're looking at your models that you're understanding those negative and positive values. So, for example, in the section on the left, you'll see that those 3 triangles that have the negative x in it, the minus x, that's pretty obvious because it's at the beginning. Where you want to make sure your understanding is on the right side where you've got those minus 8 circles. You want to make sure that you've got that in as a minus, as a negative. All right, so just make sure you're mindful of that when you're setting up, because a lot of times you'll see these problems in the form of a model. Sometimes even the answers will be in the form of a model. So, all right, so with this, similar to what we've done in the previous problems, we are going to combine our constants and then our variable and coefficients. So I'm going to get rid of my negatives again because I don't like having negatives in my problem. It actually doesn't matter. You know what, I tell you what, I'm going to do the opposite this time because maybe you're one of those unusual people that just loves working in negatives. So I'm actually going to get rid of my positives. How about that? And we'll just do it backwards, and we'll see that we'll get the same answer. So let's start by combining constants. So I'm going to go minus 10 on both sides. So I'm going to end up with 0 here. I'm going to end up with negative 3x equals 5x minus 18. Okay? Now I'm going to combine my coefficient variables. So I'm going to subtract 5x. And so I'm going to end up with negative 8x equals negative 18. All right, now I need to isolate x, so I'm going to divide both sides by negative 8. And I'm going to get x equals 2 and 1/4, or 2.25.